welcome Bill McKibben.
Well, thank you very much. And what a pleasure to get to join you all. It's a beautiful day on this side of the Green Mountains. Going to be hot and sticky, but that's appropriate, I guess. And it's a great pleasure to get to speak to you all over across on the other side of the state. I confess that as a loyal son of Middlebury, my sense of the rivalry with Dartmouth is always keen. I, for many years, was the faculty advisor to the Nordic ski team at Middlebury. And the epic battles between Dartmouth and Middlebury on the slopes on the trails at Breadloaf or over in Hanover are epic in my mind. But my daughter has just moved to Norwich and is going to be doing a little teaching at Dartmouth beginning in the fall. So I guess I have to reconsider my prejudices. And this is a good way to start. It's a pleasure to get to join you. Probably more of a pleasure for me than it's going to be for you. My work in life, I think sometimes is just to be a professional bummer outer of people. And so it's in that spirit that I will talk today. I will try to end on as optimistic a note as possible, at least with some ideas about what we can do. But we're going to go through the valley first for a little while because there's no way to figure out the scale and pace of solutions that we need unless we understand the scale of the crisis that we're in. And in order to do that, I think I may back up a little bit and go back in towards history and then move to where we are now, because it strikes me that this summer, and indeed in some ways this week with the release of the report from the Intergovernmental Panel on Climate Change, is kind of a hinge moment in our encounter with climate change. At some level, scientists have known that something like this was coming for a very long time. It was in the middle of the 19th century that scientists first really began to work out the ways that CO2 trapped heat, including the underlooked American scientist Eunice Foote, who wrote an important paper on all of this in the mid-19th century and had to have it delivered at the scientific meeting by a man because they wouldn't let women talk about such things back in those days. But she deserves a gold footnote in our scientific history. By the end of the 19th century, the great Swedish chemist Arrhenius, who later won the Nobel for other work, was doing extensive, I guess you'd by now call them sort of back of the envelope calculations about what would happen if, as he poetically put it, mankind continued to evaporate our coal mines into the air. That is, as we continued to burn in ever larger quantities coal and gas and oil. And Arrhenius's calculations about how much the temperature would go up were surprisingly accurate. They're not that far off from what we get with our supercomputers now. But for most of the 20th century, that scientific caution was largely ignored. One, because we had other things on our minds, including using fossil fuel to build a new kind of prosperity and ease on our planet. To the extent that scientists thought about it at all, it was usually with the notion that the oceans would be able to soak up any excess CO2 that human beings were producing. But in the mid-1950s, a pair of professors did some work to determine that, in fact, that wasn't what was happening, that the oceans were already at saturation, as it were. And so they speculated that CO2 must be accumulating in the atmosphere, because CO2 is an inevitable byproduct of fossil fuel combustion. When you burn coal, gas, oil, wood, you take the carbon I mean, just to give you an example, just to give you a sense of the scale of this and to understand why it's different from other pollution. We're not talking about a trace gas when we talk about CO2. If you take a gallon can of gasoline, which weighs what, about 8 pounds, when you burn it, the carbon atoms in that gasoline join with the free oxygen atoms floating in the atmosphere to form CO2, and that 8-pound gallon of gasoline becomes about 22.5 pounds of CO2. So in the 1950s, these scientists reckoned that this stuff must all be piling up in the atmosphere if it wasn't going into the ocean. And they commissioned a young graduate student, a man named Charles Keeling, to go to Mauna Loa in Hawaii, I'm told that you want more volume from me. I'm not quite sure how to produce it, but I will do my best. See if that helps at all. It may just be that I'm growing feebler as time goes on. They sent this man, Charles Keeling, off to Hawaii, and he erected on the side of Mauna Loa what's arguably the most important scientific instrument the world has ever seen. And that instrument merely measured the concentration of CO2 in the atmosphere. They switched it on in 1959, and within a year, it was very clear that the amount of carbon in the atmosphere was indeed going up. And it has gone up every year since then. And it's gone up at an increasingly steeper angle every year since then. You've seen this famous Keeling curve or a chart of it. I'm not using PowerPoint today because, because I prefer virtual PowerPoint. If I'm doing it right, the picture should kind of appear in your mind. But that famous curve is sort of the curve of our destiny as a civilization. Even though we understood now that carbon was growing in the atmosphere, we didn't understand exactly when it would cross the line to become a problem, how much was too much. And it wasn't really until the 1980s that we had the supercomputing capacity to make good approximations of where the danger line lay. There were a number of people making those calculations in the 1980s, some of them working for the big oil companies, and we'll come back to that in a little while. But the key figure in public terms was a NASA scientist named James Hansen, a physicist born and educated in Iowa, got his bachelor's, his master's, and his PhD from the University of Iowa, and went to work for NASA doing work on the climate of Venus, work that translated quite easily into starting to figure out what was happening as we added this carbon dioxide to the atmosphere of the Earth. Hansen was doing this work, interestingly enough, in the middle of Manhattan. We understood the fate of all the world's ecosystems from an office on a couple of floors above 112th and Broadway. The bottom floor of that building was the diner from Seinfeld. So there you go. In 1988, Jim Hansen went to Congress to testify. He testified in June of 1988 in the midst of an extraordinary heat wave, at the time, the worst summer heat wave that we'd experienced in the US, enough heat and drought that barge traffic on the Mississippi had been shut down. So people were paying attention when he got up to speak. And what he said was, for the first time, that we had enough data to indicate that climate change was underway. That what the engineers call a signal to noise problem had passed the point where we could distinguish the signal of climate change from the noisiness, the up and down annual variability of the climate system. Well, this was extraordinarily brave thing for Hansen to do, something for which he paid the price over many years, as at least 3 presidential administrations tried to get him fired from his job. And it was an extraordinarily important thing. It instantly turned what had been a minor scientific question into the most prominent of public issues. The New York Times ran a big story across the front page the next morning, and within a few months, Time had the planet on its cover as Planet of the Year. People took it very seriously. Indeed, the Republican then in the White House, or running for the White House, George H.W. Bush, the elder Bush, declared straightforwardly that we needed to fight, as he put it, the greenhouse effect with the White House effect. There was a moment of rare unity around the need to really dig in on this question. It was not, however, a moment of unity that lasted very long. And this is where the story, I think, begins to get very depressing. Up until this point, it's been a story about the best of the human spirit, the enormous scientific gifts brought to bear, the teamwork across disciplines that allowed people like Hansen to produce their science, and that then united climatologists around the world in this intergovernmental panel on climate change. That's a remarkable chapter in the history of science. And the correct public reaction to this news, the idea that we would need to take action. But of course, there's a different side to the human story as well, a darker side, and that quickly began to manifest itself. We didn't understand this all at the time because it was going on behind closed doors, but we know a lot more about it now, especially thanks to great investigative reporting from places like the Los Angeles Times or the Pulitzer Prize-winning website Inside Climate News, the people at Columbia Journalism School. What they discovered by talking to lots of whistleblowers and digging through archives stored away in cardboard boxes in various places was that during the 1980s, the big oil companies had been doing the same work that Hansen was doing to understand climate change. And of course, if you think about it, this shouldn't come as any surprise. I mean, Exxon was, in those days, the biggest company on Earth, and by a fairly large margin. And its product was carbon. So of course it was going to turn loose its remarkable staff of scientists on this issue. And when they dug into it, they found just what Hansen was finding. And they told their bosses what was going on. By the early 1980s, Exxon's scientists were making what turned out to be uncannily accurate predictions of what the CO2 concentration and the temperature would be by 2020. If you go look at the numbers, it's, well, it's scary how right they were. And they were believed. Their bosses in the executive suites took seriously what their scientists were telling them, as you would expect managers to do, and they began to make the changes within the business to cope with that. Exxon, for instance, began building its drilling rigs higher in order to compensate for the rise in sea level that they knew was on the way. What they didn't do, of course, was tell any of the rest of us about any of this. And instead, they embarked on the truly unwholesome and unsavory tack of building an architecture of deceit and denial and disinformation. We know now that beginning in about 1990, so within a year or two of Hansen's testimony, they'd rounded up many of the people who once worked for the tobacco industry and set them to work doing the same kind of job, building this sense that we didn't know what we knew about climate, that we didn't understand, that there was lots of doubt, that who knew what was going to happen, that we didn't need to act quickly, on and on and on. And I think, well, let's say that they were highly successful at this task, in that they were able for 30 years to lock us into a sterile debate about whether or not climate change was real. A debate that we now know both sides knew the answer to at the beginning. It's just one of them was willing to lie. And it turns out to be the most consequential lie in human history because it cost us 3 decades' time. And time, as I'll return to, is the single crucial variable in this fight. So where are we 3 decades later? We're at the point where finally that denial is beginning to wear out. And the reason there's several reasons it's beginning to wear out, but the most obvious of them is that it's plain to anybody with eyes to see just how bad this situation has become. Let's do some very simple math here. So far, humans have raised the temperature of the planet about 1 degree Celsius. That doesn't sound like that much. It's about 1.8 degrees Fahrenheit. So if it's, was 80 degrees when I started this talk and it's 82 degrees when I finish, you won't be able to tell the difference, But the planet can tell the difference because all that extra energy is aggregated over this vast planet. In fact, it's easier sometimes if you do this work in other units. The extra heat that we trap every day because of the carbon we've thrown into the atmosphere is the heat equivalent of about 400,000 Hiroshima-sized explosions every day. Now, if you think about it in those units, it's easier to understand how we've managed to, say, melt most of the sea ice in the summer Arctic, take a meters-thick, continent-wide, eons-old sheet of ice and reduce it to blue water, which incidentally amps up the whole reaction because now you've taken away the nice white mirror that reflected most of the sun's rays back out to space and replaced it with blue seawater that absorbs most of it. That 1 degree has been enough to cause remarkable chaos already in the physical systems of our planet. And we're seeing that play out this summer. We've seen it play out for the last decade or two, but with accelerating consequences. And this summer is a good example. We're seeing truly epic heat waves. We think yesterday may have set the highest temperature ever recorded in continental Europe. It was 119.8, so rounded to 120 in Sicily yesterday, which helps explain the enormous forest fires now burning through Greece and Turkey and much of the Mediterranean. We've seen epic heat waves in other parts of the world, of course, too. I think the scariest one actually was in late June across the Pacific Northwest in Canada. And scary because it was breaking temperature records not by 1 or 2 degrees, which is what normally happens if you're going to get a new record, which is rare in the first place. If you have a long temperature record, obviously, if you break it, it's going to be by a very small amount. That's how averages work and records work. But this heat wave was truly anomalous, and places were breaking their old all-time temperature records by 4, 5, 6, 7, 8 degrees. The temperature in British Columbia reached 122 degrees Fahrenheit in Lytton, British Columbia, a town that burned to the ground the next day in an extraordinary forest fire. 122 Fahrenheit is probably the hottest it's been in Canada in millions of years, long before human beings. Those heat waves and the fires that come with them are part of the quick unbalancing of the planet's hydrological cycle, the way that water moves around the planet. When it gets, well, if you wanted one physical fact to understand this century, you could do worse than warm air holds more water vapor than cold. That means that in hot, arid places, you get more evaporation than you used to. And that's why you get the drought, and that's why we have these incredible fires. And by the way, the worst of the fires burning around the world now are not the ones in Oregon or Greece or wherever we have cameras to take pictures of them. The worst are in Siberia. There's more of Siberia, more of that boreal northern forest on fire than all the other fires in the world combined right now. It really isn't supposed to be burning up there. We're seeing forest fires several degrees of latitude north of where we used to, just because it's gotten so hot and dry. And that smoke from those fires obviously adds to the burden of carbon in the atmosphere, along with, turning our skies here hazy. Yesterday, apparently, the skies above the North Pole were choked with smoke from those Siberian wildfires. So think about that for a minute. In any event, once that water vapor has evaporated up into the atmosphere, it's going to come down. And increasingly, it comes down in downpour and deluge. And that's what we see in our part of the world more than anything else. The number of storms that drop more than 2 inches of rain in 24 hours, the kind of gully washers that do farmers no good, really do nobody any good, those kind of rainstorms have increased more than 50% in the Northeast over the last 50 years. In fact, if you want to find one set of public officials who you'll never get an argument with about climate change, go talk to the guy who runs the DPW in your town, because they've long since figured out that the old book about how big a culvert you need to put in at a stream crossing doesn't work anymore. And they've been rewriting the book systematically, pulling out 10-inch culverts and putting in 14-inch ones all over New England now for decades, just because when it rains more than we can possibly deal with. These changes, even at 1 degree Celsius, are already interfering with the biggest physical systems on the planet. It's clear, pretty clear by now, that the melt of the Arctic Ocean and the rapid increase of temperature in the far north has begun to play tricks on the jet stream. As the temperature flattens out between the poles and the equators, it's not working the way that it used to, and it's tending to get stuck in these systems, and one's either on the wet side or the dry side of those systems, and that's part of what's driving our extraordinary weather. We also think, and there was new data about this within the last month, that the Gulf Stream, if you want to think of that as the kind of marine equivalent of the jet stream, another method of transporting energy between the tropics and the poles, it's breaking down too. As fresh water pours off Greenland, and as other mechanisms in the ocean begin to kick in, it looks like the salinity and hence density differences that drive these great currents are breaking down. And that's extraordinary. If it happens, we'll see perverse and extraordinary results across parts of the Northern Hemisphere, which could get suddenly very much colder, even as the rest of the world continues to warm dramatically. At any rate, the scale of things we're monkeying around with is impressive. That's at 1 degree. So the scary part of this story is not what's happened so far, it's what going to happen next, because we're still fairly early in this saga. On current trends, even if we keep the promises that we made in Paris, 6 years ago now, even if everybody kept those promises, the temperature would increase roughly 3 degrees Celsius, so 5-6 degrees Fahrenheit. And I think it's fair to say now that if we let that happen, it's highly questionable whether we can have civilizations like the ones we're used to having. Our sense of just how much chaos has been unleashed at 1 degree Celsius is terrifying when you think about 3 degrees, because it's not going to be 3 times as much damage. These things don't go linearly. Because of the tipping points embedded in these systems, they're likely to go very exponentially. And so 3 degrees is to be avoided at all costs. Our job now, and it's probably the biggest job that human beings have ever faced, is to figure out how to hold the temperature increase to 2 degrees Celsius or less, or 1.5 if we can. This is what we committed to do at Paris as a world, but as I say, we're not doing it at the moment. It's not that 1.5 or 2 degrees Celsius are going to be good outcomes. They're not. I mean, if 1 degree melts the Arctic, we're idiots to find out what 2 degrees will do, but we're probably going to find out, or close to it. If we want to slow things down, if we want to meet those Paris targets, then we have an extraordinary job ahead of us. And we have, almost a literal deadline. The Intergovernmental Panel on Climate Change, whose report came out this week, in their last update on the Paris targets, which came out in 2018, said that if we had not cut emissions in half by 2030, then our chances of meeting those targets that we set in Paris were by the board. Obviously, cutting emissions in half around the world by 2030 is the definition of a very big task. It's on the bleeding edge of the technically possible. And I don't need to tell you what a big task it is. You all know enough about how politics and economics work. You all know enough about inertia to understand why this is so difficult. But let me give you for a minute the reasons that it's not impossible. The things that are breaking in the right direction right now. There's not that many of them. This won't take as long as the depressing part of the talk, but there are some things about from which we can draw some hope. The first of these is that the engineers truly have done their job. Over the last decade, we've dropped the price of solar power and wind power by an order of magnitude, by about 90%, to the point where this is now the cheapest way to produce power on planet Earth. And the batteries to store that power are now on the same kind of plummeting cost curve. So the fact that the sun goes down at night or the wind sometimes stops blowing is no longer the obstacle that people for many years thought that it would be. And that's very good news. That gives us a chance. It really is magic, what we've done, and we should stop sometimes and appreciate that. We don't appreciate it so much here because a solar panel is, just replaces what we already had, and the light that comes on when you flip the switch is the same, and so we don't think about it that much. But when you see it in action in other parts of the world, you do get a sense of the miracle that it is. I got to do some reporting in different parts of Africa for the New Yorker about very rural and remote places, Cote d'Ivoire, Ghana, Tanzania, that had never had power and were never going to get power. The grid was never going to reach their villages. there's about 1 billion people like this on the planet. There are more people without electricity now than there were the day that Edison invented the light bulb. But the price of solar panels all of a sudden is so cheap that people are beginning in quite large numbers now to get access to electricity from the sun. And it's very, very moving to watch that happen. I remember sitting in a village in Ghana with the village elders. It was the day after people had installed a 40-panel solar system for this village and put rudimentary wiring to the huts that comprised it. And the elders there kept handing me cold bottles of water to drink, which I was very grateful for because it was right on the equator and hot as hell. And, and I'm from the mountains of Vermont, so I'm not good at great heat. It took me 20 minutes in my clueless Western way to figure out why they were so proud to be handing me bottles of cold water. Until the day before, there'd never been a refrigerator in this town. There'd really never been a cold thing in this town. So when you think about it that way, that you can now point a sheet of glass at the sun and out the back comes cold and light and information. That's that's Hogwarts scale magic. And we should be doing everything we can in every part of the world to be building it out at the most rapid pace. This should be the task that humans take for themselves. So that's good news. But left to mere economics to drive this transition, it won't come anywhere near fast enough. Yes, in 75 years, the world is going to run on solar power and wind power because it's cheap. But if it takes 75 years or even 40 years or even 25 years to get there, then the world we run on the sun and the wind will be a broken world. And our job, therefore, is to speed that up, to catalyze that change. And that's why the other thing that's happened over the last 10 years is equally important. And that is finally the building out of big movements to confront the fossil fuel industry, begin to rebalance the politics here and force the issue. Now, people sometimes give me some credit for having helped build these movements. And indeed, I did, with 7 students at Middlebury, launch 350.org, which became the first iteration of a global climate movement. So that's good, but truthfully, I kick myself more than I pat myself on the back, because it took me a long time to realize what we should be doing. I, probably because I'm a writer and an academic, was fooled into thinking that we were engaged in an argument here. And so for 15 years or so after I published The End of Nature, I just kept producing more books and holding more symposiums and writing more op-eds and on and on and on. And I think there were a lot of us like that who thought that if we'd win the argument, then of course our leaders would do what was necessary and take action. Why wouldn't they? Took me too long to figure out that we'd long since won the argument. By the second assessment report of the IPCC in 1995, the scientific consensus was firmly established. The argument was over. We'd won the argument, but we were losing the fight, because the fight wasn't about data and reason, it turns out. The fight was about what fights are always about: money and power. And the fossil fuel industry had enough money, the richest industry in the world at the time, that it therefore had the requisite political power to delay significant action on climate change for a very long time. It turned out that it was willing to keep its business model alive, even at the cost of breaking the planet, and even though they knew this cost. And that's why these movements became so important. Not only to help spread the word about climate change, but also to help build a political counterbalance to the power of the coal and the gas and the oil lobbies, which is extraordinary power. I mean, remember, in our country, for example, the most important important political player for decades now has been the Koch brothers. They own a political party. They're the biggest they donated more money in the election cycle before last than the DNC and the RNC combined. And they're our biggest oil and gas barons. Refinery giants own the pipelines that transport this stuff. So the rise of these movements has been altogether good. 350.org was, as I say, our first iteration. We've organized rallies in every country on earth except North Korea. And we sort of spearheaded some of the good confrontational work that put these issues on the map, helped launch the fight against the Keystone Pipeline, which turned into the first big defeat for big oil in that sense ever. And the best result of that was been that they get fought everywhere now, and people win a lot of victories against pipelines and coal mines, and fracking wells and LNG ports, and on and on and on. And we also spearheaded this fossil fuel divestment movement, about which more in a moment. The best result, though, has been that so many others have flooded into this space and are now truly important. The Sunrise Movement here in the United States, the young people who brought us the push for a Green New Deal. Extinction Rebellion across much of the planet. Maybe most beautifully, the rise of high school and junior high school students, exemplified by Greta Thunberg and these school strikes. Greta is one of the best people in the world. I adore her. I love working with her. She'd be the first to tell you that the best news is that there are 10,000 Greta Thunbergs scattered around planet Earth, and they have 10 million followers. If you have any doubts about whether the young people are doing their job here, put them to rest. They are. So these movements now have huge work to do to make us move in the time that we have. And we basically have two sources of power to go after in different parts of the world. One of them's political power, and one of them's financial power. So in our context, think Washington and Wall Street, but every big country has its Washington and has its Wall Street too. The fight on political terms is always hard and always important to engage. And it's at a crucial moment right now in Washington. We've come 30 some years since Jim Hansen's testimony without any significant federal action on climate change, congressional action on climate change. But that could change. The two infrastructure bills now making their way through the process are a beginning. Truthfully, the first infrastructure bill, the one that's already been approved on a bipartisan basis, doesn't do much on the climate. It gives big oil a fair amount of the wish list that it's put forward. It's not going to help much, except that it's the thing that unlocked the politics that might allow the second infrastructure bill, which will need all 50 Democratic votes to approve it. It'll have to be passed by Prime Minister Manchin of West Virginia. But if it happens in anything like its current form, then there really will be, for the first time, a significant amount of federal spending on the transition that we need, on the chargers for electric cars, on rebuilding the grid, on providing the resources to take communities, especially poor communities, and outfit their homes, people's homes, with the things that now make it easy to avoid carbon. Air source heat pumps in place of oil or gas furnaces, induction cooktops in place of gas stoves, on and on and on. The hope is that this is the money that will start unleashing the technology that now exists at scale enough to make a huge difference and be emulatable in many other parts of the world as well. Will it happen? Look, our political system is stressed and strained in ways that none of us have ever seen in our lifetimes. I'm not sure we even quite think about it enough, but so far this year, we've made it through an attempted insurrection to overthrow the way we count votes in this country. We're in a bad place. This is a hard time to be trying to do something big. Give what support you can to Mr. Biden and his colleagues as they try to make this happen in the Senate. It's a key question. The irresponsibility of the Republican Party in this context is astonishing, because, as I say, it wasn't there at the beginning. George H.W. Bush was prepared to take it seriously, but the fossil fuel industry has overwhelmed good moral sense now for a long time, and we're in a very dark place. So I don't know what'll happen. I spend as much or more time thinking about the other power center, Wall Street and finances, because I think it's equally important. About a decade ago, a couple of us launched this fossil fuel divestment campaign to get institutions and others to sell their fossil fuel stock. It was a campaign modeled on the one about apartheid from a generation ago. And I know that that campaign brings back some unhappy memories on the Dartmouth campus, because I know that it was a time of sad and irresponsible action by some students and things at Dartmouth. But it was an important moment. That campaign against apartheid and the divestment component of it were really important in bringing change. So we thought we'd try to do the same thing here. And it's gone better than we thought. It's emerged into the largest anti-corporate campaign of its kind in history. We're at $15 trillion now in endowments and portfolios that have divested in part or in whole. These include, well, just anyone you can think of. The Pope and the Queen of England, the greatest educational institutions on the planet, Oxford, Cambridge, the University of California system. It includes the pension funds of, say, New York State or New York City, or hundreds of other places. It includes the sovereign wealth fund of Norway, the single biggest pool of investment capital on planet Earth, and one that was raised mostly by drilling for North Sea oil. But the Norwegians are smart enough to say, look, we're taking our money out of that and moving it somewhere else. This campaign has been driven by two things. One is the immorality of what the oil companies are doing, and so the desire to take away their social license to do it, which is why it's been so important to have high-profile institutions, including, happily, I will say, Middlebury College, among thousands of others, divest their holdings in fossil fuel. Not, I fear, Dartmouth at this point, though one hopes it will eventually, given particularly Dartmouth's tremendous track record in researching these questions and its particular connection to the Arctic and to the places that are the real canaries in the literal coal mine here. The other reason that it's been effective is it turns out we were excellent investment advisors, despite not having the slightest idea about such things. The fossil fuel industry has been the worst performing part of our economy over the last decade. If you'd invested in literally anything else, you would have done better. And that's not too surprising, actually, when you think about it. The fossil fuel industry's product is destroying the planet, so eventually it's going to come under regulatory pressure, and people are figuring out how to provide the same product, energy, just cheaper and cleaner. So it's not a good business to be in, and it's not the biggest industry in the world anymore. In fact, Exxon, which was the biggest company on earth for many years, is now not even the biggest energy company. They were passed in market cap last autumn by NextEra Energy in the Florida-based renewables provider. That's where the next tranche of money is going to be made. At any rate, let me, as we're getting winding on towards the end here, let me just say a few things about what has to happen if we're serious about making change in the time that physics is allowing us. Because remember, in the end, this isn't a negotiation between Democrats and Republicans or industry and environmentalists or anything else. In the end, it's a negotiation between human beings and physics. And that's a tough negotiation because physics is poor at compromise. It's going to do what it's going to do, and it's setting the terms here, and our job is to obey them. And I will repeat something I said earlier. It's a timed test, and we're not good with timed tests in our political life. We don't have many of them. I mean, we've been arguing about things like national health care as long as I've been alive, and eventually, I think we'll probably get it because every other industrialized country in the world has it. And it'll be a shame that we didn't have it before. A lot of people will have gotten bankrupt or died as a result, but it won't make it harder in the end to eventually do it. Climate change isn't like that. Once the Arctic's melted, no one's got a program for how you refreeze it. So time is of the essence. What can we do to help? This is a hard question here because I know when people ask it in completely good faith, they're asking, what should I be doing in my own life or whatever? One of the hardest things about climate change is it seems very large and we seem very small by comparison. It seems unlikely that we could have an effect on the outcome. And I think that intuition is in many ways accurate. I'm not saying don't take individual action. I'm highly proud of the solar panels all over my roof and the electric car they're connected to, and on and on and on, yada, yada, yada. But I do not try to fool myself that that's how we're going to deal with this problem. If we had 75 years, maybe, but we're past the point where you can make the climate math work one Tesla, one vegetarian dinner at a time. The most important thing an individual can do is be less of an individual and join together with others in movements large enough to change the basic political and economic ground rules here, to do things like pass this infrastructure bill, or to force the fossil fuel, to force the banks to stop lending to the fossil fuel industry. Which has been a big part of this, it's what this divestment effort has morphed into over the last few years. And I want to end here by making a particular point that older Americans have a crucial role to play here. They have a huge debt, obviously, to pay because it's on our watch and in our nation that so much of this carbon got poured into the atmosphere. So we have a debt to pay back, and we have the capacity, I think, to do some of that, to pay it back in serious ways. The youth are organizing with remarkable power, and it's time for the rest of us to join them. We'll be launching within the next month or so a formal effort about this. We're going to call it Third Act, because, the first act of many of our lives is pretty interesting. We were around for the civil rights movement and the anti-war movement and the women's movement and real changes in our culture. Second act of our lives, maybe not quite so interesting, somewhat more privatized, Now we're emerging into the later act of our lives, the last act of our lives, with a lot of resources, a lot of skills, often a lot of grandchildren, and hence some serious angst about what kind of legacy we're going to be leaving behind. And we've got the ability to do something about it. So for instance, because it's going to be one of the first campaigns we undertake, you should know that the biggest banks in the world are the lifeline to the fossil fuel industry at this point. Since the Paris Climate Accords, the big banks in the world have lent the fossil fuel industry more than $3 trillion. The biggest of them, JP Morgan Chase, more than $250 billion just by itself. They did not need Donald Trump to sabotage the Paris Climate Accords. They were quite willing to do it themselves. We've begun to put real pressure on them. My last trip before the pandemic was to jail in Washington, D.C. We sat down in the lobby of the Chase branch nearest the nation's capital and were arrested for our pains to kind of launch some of this work, which now, as the pandemic begins to recede a little bit, it's time to take up again. And we're the people to take it up because, older Americans have more than their share of the country's assets now sitting in their bank accounts and retirement accounts. If BlackRock and Vanguard and Chase and Citi and Wells and Bank of America and whatever are going to listen to anybody, it's people like us. I'll just finish by saying that I hear a lot now from older people who want to take part in this fight. And often they'll tell me, and it makes me kind of happy to hear it, that one of the items on their bucket list is to get arrested before all this is done. I'm not telling you that's the only thing that matters, but I'm telling you that it's the right way to be thinking. And I'll finish with a story from the beginning of this fight against the Keystone Pipeline. I wrote the letter that asked people to come to Washington exactly 10 years ago, August 2011, to start this fight against this pipeline coming down from Canada carrying tar sands. Because Jim Hansen, still super active in the fight, had pointed out that, as he put it, tap the tar sands of Canada and it's game over for the planet. There's so much carbon up there. When we started, nobody thought that we could win. The National Journal, which is kind of the trade paper in DC, had polled its 300 energy insiders on Capitol Hill, and 91% of them said that the company would have its permit to build the pipeline by the end of 2011. But then more people went to jail than had gone to jail about anything in this country in a long time, and that kicked off the fight that got Obama to withdraw the permit. Trump put it back in. Biden finally, earlier this year, put the kibosh on it once and for all. But the point I want to make is, when I wrote the first letter asking people to come, one of the things I said was, I don't think college kids should actually have to be the cannon fodder here. If you're 22, it's possible an arrest record, not the very best thing on your resume. But past a certain point, what the hell are they going to do to you? So it was with great pleasure that I watched a lot of people with hairlines like mine arriving in DC. We did not ask people as they were getting arrested, how old are you? That seemed rude. But we did, cleverly, I think, say, who was president when you were born? And the two biggest cohorts came from the FDR and the Truman administrations. On the last day, there was a guy arrested with a sign around his neck that said, World War II vet, handle with care. He was old enough that he'd been born in the Harding administration, which was a long time ago. The point is, it was really useful for the young people who were there to see their elders acting the way that we need elders acting, not necessarily getting arrested. That's just one small part of this work, but taking responsibility, taking the heat, doing what they could to set things right. And we're going to need a lot more of that in the time ahead. I'm not going to tell you that even if we do everything right at this point, we're going to win this fight, because we do not know. The physical momentum of these systems is staggeringly large and scary. And, Eric will tell us more, but how it's all going to play out at this point is, well, there's not a good outcome here, but there may still be room for less bad outcomes. And it will depend, I think, above all, on how much and how quickly and how effectively we mobilize to demand change. We've got the technology now that we need. The miracle technology has been provided. And so the question now is whether or not we rise to the occasion. And an important part of that rising will be people like us in places like this. If you've been keeping your powder dry, keep it dry no longer, because as the IPCC pointed out earlier this week, we are at the climactic moment. So I'm going to end there and just say thank you for bearing with this. And if you've got questions, then I look forward in a few minutes to trying to answer them. And I look forward immensely to hearing from Eric. And thanks to all who made this possible.
And thank you all for joining us today. I want to begin just by, on behalf of everybody here, saying thank you to Bill for a wonderful talk. And I think for me personally, a lot more than that, right? You've been a leader on this issue for so long and a pioneer on this issue. And when I think about, you talk a lot about James Hansen, and there are other people like Wally Broker who are sort of leading the charge from the science perspective. But what we need is people who are really good at translating that science and communicating it to everybody. And you have really been a leader in that going back for decades. So I know you say you're a little reluctant to pat yourself on the back too much, but please allow me to pat you on the back and say thank you. And this is also quite special for me because I am a proud son of Middlebury College as well. So it's great to have you with us. We have a ton of really fabulous questions. Thank you all for the questions you submitted. I've been trying to organize them in terms of questions about the problem of climate change. And then we've got a lot of questions. The majority of questions are about solutions and implementation of those solutions. So maybe we'll spend about 15 minutes on some of these problem questions and then move on to solutions. And so again, if I'm not able to make it to your question, I do apologize. We're doing the best we can with the time we have here. So let's start with some of these questions about the problem. So Ellis Rowlett asks, will climate change that we've already seen persist indefinitely into the future no matter what we do? Or will climate change actually reduce in its impacts if we're able to meet these aggressive CO2 targets that you talk about?
Well, Eric, you're as good at answering this as I am, but the emerging, I think the one kind of hopeful piece of emerging science in recent years has been and Mike Mann has written a lot about this, has been a kind of sense that if we were able to drive emissions to zero quickly, that the temperature would respond fairly quickly to that, which is good news. I mean, it's better news than the temperature just keeps rising forever. I don't think, however, that's I think there's a bunch of caveats with that. There's a huge amount of most of the heat that extra heat that we've trapped has been stored in the oceans. And that's going to go on expressing itself for a long time in a lot of ways. And I don't think there's anyone who thinks, I mean, this is obviously your specialty, but that, the melt of the polar areas and things is the momentum that's built up there is enormous. But it's really important for people to understand that that this is a fight worth having, that there's all the difference in the world between a planet that settles at 2 degrees warmer and a planet that settles at 3 or 4 degrees warmer. The former is going to be miserable, there's no doubt, but the latter is likely to be impossible for our species anyway, and probably a majority of the other species that we share the planet with. So one wishes that one was able to say, I'm aware that it doesn't quite rise to the level of like, I have a dream or something to say, we want to stop the increase in temperature at 1.5 degrees Celsius instead of 2.5 degrees Celsius. But that may be the most important choice humans ever make in their career as a species.
Yeah, that's a great point. And I think the new IPCC report that just came out this week one of the things that they do really nicely in this report as an improvement over prior reports is really showing nicely the difference between that 1.5 degrees Celsius warmer world versus the 2 versus 2.5 or 3. And as you said, it's not a linear relationship, right? These things don't just get progressively worse. In many cases, these are exponential relationships. And I totally agree with you. It really depends on which part of the climate system you're talking about. I think you're right that the ice sheets are a tough train to slow down and certainly to reverse. But temperatures should respond pretty quickly. And I think the science is very clear on that temperatures respond quickly to the CO2. And so, things like mountain glaciers should grow back quicker, but the big ice sheets are going to be tough to slow down, particularly Antarctica. We've got a question about the role of deforestation. We talk a lot about fossil fuels. How does deforestation play into the problem here?
Well, it plays in a couple of ways. One, the process of deforestation releases a lot of carbon, no matter how you do it. But especially if you do it the way we mostly do it, which is burn things down in the tropics in order to start planting them. And two, it's we've come to understand more and more and more what a great sink for carbon forests are, especially old forests. There's been a lot of work in the last couple of years, last 10 years, a lot of it done by our colleague Bill McKibben at Tufts. And the numbers are really amazing to look at in terms of how much big old trees actually manage to sequester. And it's one of the reasons why of all the dumb solutions that we've come up with for one of the worst is probably the wholesale cutting of forests in order to chip them and put them in plants to make electricity. This is now getting ahead of steam, as it were, because the Europeans, the EU, which does a lot of things right, has, for various reasons, decreed that burning biomass in this way to produce electricity is carbon neutral, but it isn't. The math doesn't work. Yes, it's true that if you cut down a tree, another one will grow in its place. But given that we're breaking the back of the climate system right now, it doesn't make that much difference what happens 50 years from now when that tree is growing. And this strays from the question a little bit, but I think a way that I've been increasingly trying to help people, get people to sort of understand the basic challenge here is we have to stop burning things on planet Earth: coal, gas, oil, wood. And combustion has been what we've done as a species for a very long time. It's very ingrained in all our systems, but it's no longer necessary because we can take advantage of the fact that the good Lord thoughtfully provided a large fire burning 90 million miles away that we now know how to take full advantage of. So burn nothing on the planet, burn everything, in orbit, and then we're cool.
That's great. I like that a lot. How do you think about agriculture? So some people have said, agriculture is just as big of a problem as CO2. This is a question from Mary Mitchell.
Yes.
How do you see it? My understanding from just the raw science of it in terms of what different industries cause what proportion of climate change is that agriculture is somewhere around 20% responsible for what we see. Is that how you think about it?
Yeah, and this connects with the deforestation question. Agriculture is 18%, I think, of the FAO said most recently. And most of that, or a lot of that, is linked to deforestation to allow new pasture land. So agriculture is a big player here. And happily, there's interesting work going on around regenerative agriculture because soil could be a major sink for carbon. The reason not to think of it as a silver bullet in the short term is A, the science isn't there yet. We don't, I mean, and it's extraordinarily complex because, we talk about soil as if it was one thing, like the atmosphere or something, but it's not. I mean, there's every, hectare of land is different from the one next to it and completely different from the around the world. More to the point, one of the reasons we go after fossil fuel companies so much is because they're 3/4 of the problem. The other reason is, though they're extraordinarily powerful, they're a manageable target set. There's only 20 of them that count, so that's the fight. The problem with agriculture is we have 1 billion farmers on the planet, and figuring out how you change longstanding cultural practices in short periods of time is a real heavy lift. I'm very glad that people are looking hard into this. I really I'd urge people to check out the extraordinary and interesting work done at places like the Land Institute in Kansas on the perennialization of annual agriculture and things like that. And one hopes that at some point the next farm bill, say, will become a vehicle for taking some of this research seriously instead of what it is now, which is just an endless series of subsidies for Cargill and ADM and other parts of big ag. But it's important, but it's not. There's nothing simple about it. Truthfully, the only simple part of this fight is, though it's not easy for political reasons to do, is the substitution of renewable energy for fossil energy. That's technologically understood, and it's something that we're completely capable of in short order if we set our minds to it, if we get the politics right.
Yeah, I'll be interested to see that next ag bill. I think one of the things that's been most remarkable to me about the current administration in Washington is that they're really taking, for the first time, as you mentioned, sort of an all hands on deck approach here, right? It's not just like, oh, well, let's have a climate change bill. It's climate changes in infrastructure, it's climate changes in the military spending, climate changes in the energy bill, obviously. And so it'll be interesting to see if it comes up in the ag bill as well.
Yeah.
So we talk a lot about fossil fuel in terms of power generation, but we get other things from petroleum. And so we had a couple of questions about other petroleum-based industries. So thinking about plastics, thinking about asphalt.
Yep.
How do you think about those in the future as we think about trying to reduce CO2 emissions?
So plastic is the one that's really annoying here. Setting aside climate for the moment, I mean, there's just a whole host of reasons why producing plastic in large volumes is a bad idea. I mean, by sometime in the next 15 years, the weight of plastic trash in the world's oceans is apparently going to outweigh the weight of all the fish in the ocean. I mean, that should give one some sense of why it's a poor idea. The fossil fuel industry has seized on plastic as its escape route at this point, because they have this huge supply of fracked natural gas and things. And if we're going to be serious about renewable energy, then we're not going to need it. So they're building plants, especially across the Southeast, to basically turn it into plastic, cheap plastic, and doing really bad things. There was a story in the Times maybe a year ago about the fact that the plastic industry, which is largely the fossil fuel industry, was in Africa lobbying hard to get African countries to overturn their bans on plastic bags because they think it's the next great market for, Africans aren't using enough plastic in their terms. If you've spent time in places in the developing world, you know what a good thing it is that some of these countries are trying to stand up to that scourge, because among other things, all kinds of like river systems and things just become clogged and choked with plastic waste. And it's really wrong for American industry to be over there trying to do it. The essential truth here is that we've got to keep most fossil fuel reserves that we know about in the ground and not use them for anything. And there are some things that are going to be harder than others to decarbonize. Concrete, and cement are hard to decarbonize, though people are starting to come up with some plans. Jet fuel aviation is hard to decarbonize, though at least for short haul flights, it's beginning to look like we can come up with some electric alternatives. These are hard cases at the edges of things, and there's going to be a lot of work on them, but they shouldn't distract us from the basic task of this decade, which is taking the things we now know how to do and deploying them while we're doing research on how to deal with this next range of harder challenges. 2030 is a kind of interesting end date. If we can get there, having done what the IPCC told us to do, cut emissions in half by transforming our energy supply system, then I think in some sense we'll be able to take a breath and regroup and figure out how we go about solving the next half of this problem. If we don't do that in the course of this century, then it's going to be pretty moot what we do with all the harder parts of this challenge, because things are going to be it's Katie bar the door in terms of what's going to be going on with temperature.
Well, that's a good segue into some of the questions about solutions. So Zachary Hooper was asking about these targets you just mentioned, a reduction of 50% of carbon emissions by 2030. Is that enough? Is that ambitious enough?
Nothing's enough. I mean, literally, there's nothing. I mean, if we stopped emissions tomorrow, that's not enough. The level of carbon in the atmosphere is still highly elevated above what we want it to be. We're at 418 parts per million or something at the moment, and the world really, all we know is that the world works at about 275 parts per million, and past that we don't. So no, nothing's enough. But is it? I mean, would it be the greatest single accomplishment of human ingenuity to cut emissions in half this decade? Yes, that would be an astonishing feat. And if we did it, if we managed to mobilize in order to do that, then the momentum would carry us forward very rapidly. It's the hardest parts of this are the phases we're in right now, where we have to break the hold of the fossil fuel industry and begin doing things on mass scale. And once we do, then the obvious benefits and savings of a lot of these technologies will begin to become apparent to people. Some of that's already happening. You're beginning to see people understand, for instance, that like electric vehicles are just superior vehicles, even in a world without worrying about climate change. They don't have many moving parts. They quiet, they accelerate, all those sort of things. And I'll just add, since we haven't said it, but it's worth saying. The reasons to be worried about fossil fuel, now that we no longer have to depend on it, aren't confined to climate. There was a lot of work this year to indicate that breathing the products of fossil fuel combustion kill about 8.5 million people a year around the world. That's more than HIV, AIDS, malaria, and tuberculosis combined. It's 1 death in 5 on our planet. We're in unnecessary deaths now. And of course, they're concentrated in the poorest places in the world. We didn't talk much about this. I didn't talk much about this, but it's always worth remembering that climate change, as much as it's a technical issue, is also a moral one and a deep question about justice, because the iron law of this stuff is the less you did to cause it, the sooner and the harder you get hit. And it's the most unfair thing we've ever done. And if, for no other reason, those of us who have benefited from the world that fossil fuel built have an immense responsibility to do the most about it now.
It's such a huge point, Bill. It's the point that I generally end every one of my science seminars on, is coming back to that moral issue. That those who get most impacted by all these things we talk about are the ones who are least responsible for the problem, and often responsible for essentially zero part of the problem. And that's true. What's remarkable about that to me is that is true on every single scale you can think of, from right here in the Upper Valley to globally on a nation by nation basis.
One of the things we found out in Vermont and New Hampshire when Hurricane Irene came through a decade ago, where this is the 10th anniversary, I think, of Hurricane Irene. One of the things we found out was that every trailer park in northern New England sits on a floodplain. That's whose houses got washed away. And that microcosm is true of, when we had the worst hurricane season we've ever had last year, more storms. We got to Eta and Iota by the end of the year. The last two storms, because we're deep into the Greek alphabet, hit 10 miles apart, 10 days apart on the Central American coast. And they just devastated Honduras and Guatemala. We think the hit in Honduras was the equivalent of 40% of GDP. By contrast, the worst storm ever to hit the US, Katrina, did damage equivalent to about 1% of GDP. So there's lots and lots of people on the move now out of Honduras and Guatemala toward our border, because what are you going to do? I mean, your farm field is now under a foot of sand, or if it isn't, the bridge that you needed to get produce to market doesn't exist anymore. I don't know what their legal status when they get to the southern border is, because things like refugee status are lagging our climate experience, the climate chaos. We haven't yet come up with the rules we have to understand this, but their moral status is impeccable. Nobody in Honduras or Guatemala did a damn thing to cause climate change. They're a rounding error in the calculations. Always to be remembered is that the 4% of us who live in the United States produced more than a quarter of the carbon that's in the atmosphere now, the excess carbon. If 1,000 people die in some flood in Honduras, I mean, this is obviously, the math is not exact, but like 250 of them are on us. That's how it works. That's less simplistic than the kind of math that will help you avoid those sort of conclusions.
Absolutely. Doug Kogan asked about renewables, and you mentioned how we've crossed this critical economic threshold where it is now cheaper to actually produce electricity on a grid scale by solar or wind than it is by fossil fuels, which to me is an absolute game changer, because now you don't even need the climate argument. It's just an economic argument. But do renewables still need a helping hand from the government? Or if you level the playing field, will they win out?
No, I mean, eventually they'll win out. But as I said, eventually doesn't do us a damn bit of good. I mean, they've got to win out in 10 years. And the idea that there's a level playing field, by the way, is nuts. We've been subsidizing the fossil fuel industry to the tune of and continue to the tune of hundreds of billions of dollars over its history, which is, just crazy making beyond belief. I mean, this industry has enough political power that it just continues to extract gifts from Congresses around the world. But no, at this point, the renewable energy desperately needs precisely the kind of boost, a much bigger one really, that the Biden infrastructure bills are trying to provide. Because it doesn't do us any good to make this transition once the planet's a complete wreck.
Yep. I have a question. I didn't see one, maybe I missed it, but I didn't see any questions about wind power. And to me, we've seen dramatic progress on the wind front here in New England and nationally. And wind really has sort of a 10-year head start on solar, if you look at total amount of electricity produced, at least in this country. So how do you think about wind? I'm thinking about the new progress in offshore wind. Yep. And I'm thinking about the NIMBY problem, right? Like we've had very strange discussions about wind here in New England, right? Where the environmental movement has been very much against it because of the ridge lines and cutting down a forest. And it's a very complex issue. So how do you think about wind?
So it's very good to see offshore wind finally beginning to happen in this country. We're way behind where they are in Europe, but I guess that's going to make it easier in some ways here. The technology is amazing. Wind in general and offshore wind in particular are amazing technologies, mostly because you can build this stuff fast. The Brits just built an offshore wind farm that produces more power than a big nuclear power plant, and they put the whole thing up start to finish in 18 months. So that's the kind of pace we need. It drives me crazy that northern New England has been so resistant to any wind power at all. We don't need to put them on every wilderness ridgeline that there is, but I can't wait for the day when there's a big wind turbine up on top of Middlebury Gap, up there, above the snowball. It'll be a great symbol of the fact that we're taking responsibility for our own energy lives instead of, blowing the mountaintops off West Virginian, mountains or whatever it is. And among other things, we should be wanting to localize energy just as we're localizing food to the degree that we can. We're going to be going through, in the best of circumstances, a difficult century. We can sense its physical strains and its political strains now. And we'd be far better off entering that with far more ability to govern our own commodity lives, to produce more of our food and more of our energy close to home would be a very smart thing in all kinds of ways. I think that I love Vermont. Some days I think that the state motto of Vermont should be change nothing until I'm dead, and I respect that and sometimes feel a little bit myself, but we can't have that now. And one of the things we need to do is develop a new aesthetic. A wind turbine is the breeze made visible. And I think they're beautiful when they're turning on the hills, that there's something magic about them. And as I say, we don't need to put them everywhere, but we need to put them somewhere. And
I feel very, very similarly to you. Let's take on another potentially sticky energy solution, which is nuclear power. Again, one that, from a carbon perspective is a fabulous solution. From a larger environmental perspective, particularly the waste issue, is one that often the same environmentalists are fighting against. So how do you think about nuclear, especially when 20% of our current electricity is nuclear, and those plants are all going to be out of commission in the next couple of decades? I got to say, I'm, as you can tell, I'm willing to worry about a lot of things. For some reason, nuclear waste worries me less than other things. I'm willing to guess that given a few thousand years, we'll come up with some reasonable solution to what we're storing away in some mountain in Nevada or whatever. It's not great, but in terms of just general risk, everybody knows that if something goes wrong with the nuclear power plant, it's bad and it goes really wrong. We've seen enough examples. But, if you operate a gas-fired power plant exactly according to spec, it destroys the planet. So, weigh those two things. That said, I don't think that we're likely to see nuclear power as a huge part of the solution going forward. And the biggest reason is that it's incredibly expensive. The price of solar and wind has gone like this for the last decade, but the price of nuclear power just keeps going up and up and up because you have to build a vast, concrete, complex, and deliver it all centrally. And, there are people I respect, Jim Hansen, chief among them, who think that we may see a kind of fourth generation nuclear power in the horizon, not very distant future, that'll have smaller, safer, cheaper plants, and that might change the equation. But for the moment, I think you're right that if we have places that are operating with some, within reasonable safety boundaries, we probably shouldn't close them down. But I don't think this is going to be the place where I doubt we're going to see a huge build out of nuclear power, except in
authoritarian regimes that may have some designs on the byproducts for other reasons.
Yeah, I tend to agree with you. And for me personally, I view that as a shame. I would love to see James Hansen's vision come to fruition. I have my class. I have this large class I teach on climate and the whole evolution of the planet. And I have them play with the numbers and say, okay, you have to take America down to 95% reduction in emissions, but still produce enough electricity by 2050. How do you do it? And it's almost impossible for them with playing with the numbers to do it without, dramatically scaling up nuclear. But I also agree that politically and the economic part of it is really key.
Hard.
It's
the
really
guy that I think is really interesting on this for people who want to look more into it, I think the best numbers have come out of Mark Jacobson's lab at Stanford in recent years. And when he first put them out 8 or 9 years ago, saying, look, we can do all of this with wind, water, and sun, and we can do it everywhere, and we can do it cheaply. There was a ton of pushback against it, and people saying that's ridiculous, and academics, signing all these letters telling us. Truthfully, the way that the last decade has played out, it's looked more and more like he and his team were on target about what was going to be happening, money is a finite resource like everything else, and no one seems to be rushing to spend it on nuclear, which is probably a clue.
Let's switch to another potential technological solution. Peter Fahey was asking about carbon capture and sequestration. And, you started 350.org. We're at 418. So we need negative emissions.
Yes.
How do you think about CCS, carbon capture and storage, in the future and the role it might play?
So these are technologies that we're only in the very earliest days of, and we don't know how they're. The ways that we're talking about using them now are dumb. The infrastructure bill that's just going through the Senate has a lot of money for carbon capture and sequestration that the fossil fuel industry wants, because basically what they want is some system to allow them to keep doing what they're doing now, but without overwhelming the climate system. So you run a coal-fired power plant or a gas-fired power plant, and you put a filter on the smokestack, pull the CO2 out of the exhaust stream, and run a lot of pipe to put it underground in somebody's old salt mine or something and store it there. So we could talk a lot about all the technical issues around this and so on and so forth. But the basic fallacy of it is that once you've done this, it's way more expensive. I mean, if solar and wind power are already cheaper than new gas power, new coal power, what do you think gas power and coal power are going to be like once you've also added this Rube Goldberg system of pipes to get? I mean, just take the money and build the wind turbines in the first place. And so at the moment, what this stuff largely exists for is to safeguard the fortunes of the people who own oil wells and coal mines, which does not strike me as a smart use of money. And at the moment, what are we doing with the sequestered CO2? We're often pumping it into oil wells in order to produce yet more oil. So, look, stop burning things on planet Earth. That's the easiest bottom line here. At a certain point, you're right, it's going to be useful to see if various forms of capturing carbon in the atmosphere are possible. This direct air capture kind of stuff is, again, plausible, technically possible, and at the moment expensive. And, we'll see what can be done. That's my sense. But just everyone should be aware that the fossil fuel industry is now in a period of pretending to care about climate change in order to try and safeguard its business model as long as it can. And this greenwashing comes in many forms. And at the moment, that CCS stuff is one of them.
All right, we've got about 10 minutes left here. So I want to take a bit of a step back and think even bigger. So how do we've got Maxine Schuster and Bill Gilbert, and I'm sure others, probably everybody is wondering, how do we get other countries on board, particularly China, India? How do we get other countries to come along? You talked about, not being under any illusion that a single person's efforts. What about a single country?
Yes.
How do you think about this and respond to that?
In the first place, let's just be clear here. No big country has done less than we have at this point. So,
and no big country is more responsible for the problem.
And in per capita terms, no one continues to. I mean, the Chinese and the Indians are nowhere near, but we're
nowhere near
per capita terms. So, I mean, you can understand a little bit of the Chinese impatience with scolding them about this kind of stuff. And let's give credit where due. The single biggest reason that we have cheap solar power and wind power is because the Chinese manufacturing empire went to work, spurred largely by German demand 15, 20 years ago. They went to work figuring out how to do this stuff cheaply. And, so credit to them. And they're installing it faster than anybody else in the world, tons of it. But they're also putting up, they have their own, as it were, fossil fuel lobby. And so they're still putting up coal plants and so on. It's the hardest part of this thing to figure out how to coordinate international action. John Kerry has taken on the task, and good on the Biden administration for giving him the job. It sent a signal to the rest of the world that the former Secretary of State is now devoting all his efforts to this issue. It's made more difficult by the fact that how do you figure out exactly how to negotiate with the Chinese when they're in the middle of, running a kind of, country-sized concentration camp for Uyghur Muslims and building in a horrible surveillance state and on and on and on. And threading that needle is going to be hard. I think that we can safely say that the meeting in Glasgow this November will be an important step along this road. One of the reasons we have to get these infrastructure bills through the Senate in the next couple of months is to send a strong signal to the rest of the world that we're actually doing something here in the House of Carbon to address. And if we do, that'll make it easier. Second thing is, not all other countries are alike. India is about where China was on the energy curve 15 years ago. So India has the potential to be the place where a large percentage of economic takeoff is fueled by renewable energy, not fossil energy. And solar power, and India is perfectly situated for this because it gets a lot of sun. Solar power for electricity generation in India, it's now cheaper to build new solar power in India than it is merely to keep shoveling coal into existing coal-fired power plants. That's how much the economics have changed. But the politics don't completely follow them. There's millions of people who work in the coal industry in India. Prime Minister Modi's when he ran for office, he flew around the country on the private jet of the biggest coal baron in India, on and on and on. So the political problem, and that's why we organize all over the world. As I said, 350 has organized every place that we can, and including China and India. And it's not easy, but it needs to be done. So demonstrating what we can here will be an important start.
Let's talk about messaging here for a second. So Stephen Sharma was asking about how do we convince, people who are just dead set against this even being a problem, what we might call denialists or whatever. And this is something that I've been thinking about a lot as I give, seminars on this topic is how do we move past preaching to the choir?
Yeah.
How do we engage maybe not the hard denialists, because maybe they're not going to change their mind, but how do we reach those folks who are on the fence or who are open to thinking about this? And I'm sure you've thought a ton about this.
I think you raised the question in the right way. It's not worthwhile trying to change the hard denial. I mean, they're not waiting for the next issue of Science or Nature to come out and, this one more study was all I needed. Opposition in ideology, and if you'd marinated in Rush Limbaugh for the last 30 years every afternoon, you'd be nuts too. The good news is that in many ways the public opinion battle has been, if not won, it's tipped. And we're now at a point, and it's just really a development of the last 2 or 3 years, where something like 70% of Americans understand that there's a serious problem here. They don't necessarily understand the urgency quite, but they're getting it. And that's a function of movements. It's a function of the fact that it's less scary now because we have alternative technology. And it's a function of the fact that Mother Nature is a good educator and she keeps hitting us upside the head with a 2x4. But the difficult and important part now is to take that 70%, which I assume everybody on this call is a part of, and change some fraction of it into people who are concerned about this, into people who are taking political action around this, building movements in order to make change, because it doesn't happen by itself. So one way of saying it is, this is what I tell students, or at least I used to before the pandemic, like, don't ruin Thanksgiving dinner arguing with your crazy uncle. He's not going to change, but do sit down next to your sweet aunt, who's probably worried about her grandkids and things, and make some suggestions about what she could be doing. That's why we're going to be doing this third act stuff with older Americans, bringing them on board with a series of things that are useful, talking to the bank, talking to their people handling their retirement accounts, talking to their politicians, getting people engaged. It doesn't have to be everyone. You don't need the emerging literature on movement building is really interesting. It's like you almost always win when you get 4 or 5% of people engaged in a fight. And the reason is that apathy cuts both ways. We've organized the first huge climate march in the world, 400,000 people in New York City in 2014. We worried about everything. Are there enough toilets? On and on and on. The only thing we didn't worry about was that the next day, 400,000 people were going to come out and march in favor of fossil fuels. If we can get people who care to actually care in action, then we've got a shot here.
So we got 30 seconds here. How can people get involved with Third Act? We had several people ask about that.
I shouldn't even be talking about it. We're still a little bit away from, a few weeks away from launching it. So the website's not up yet or things. But if you follow my Twitter feed, which is easy to find, it's just at Bill McKibben, then you'll be up to date when we're ready to go and launch. And hopefully we'll make enough noise. And I'll send over the stuff to the good people at Osher too, and they can circulate it to the people who are here today when we're ready to.
Well, thank you again, Bill. This has been fabulous. Again, it's been a real treat for me to have this conversation with you. So on behalf of everyone here today, thank you. And I'll pass it back over to Roland.
Thank you too, Eric. You've done remarkable work, and your students are showing up all over the place, doing great stuff, which is really the point here. So many, many, many thanks. And thanks to everybody at Osher for this fascinating. I hope we've gone on a long time and people have been very good to spare with it.